Welcome to the championship final. Think about it. You've got exactly 90 minutes to glory. Your entire game plan for exam victory comes down to what happens in that room. If you're preparing for the Cambridge 0606 Additional Mathematics exam, you already know that opening that paper can honestly feel like stepping onto a field where you only kind of understand the rules of the game. Well, today, we are completely changing your strategy. We're going to decode this syllabus by treating mathematical notation not as some terrifying disconnected list of symbols to memorize, but as a clear, logical language. Because once you actually master the grammar of this language, the problem solving, it just clicks.
I want you to really lock in on this quote. Mathematics is a language. To ace the exam, you first must read the symbols. I see two types of students all the time. First, there's Alex. Alex overloads on raw math facts but uses zero analysis. Then there's Sam. Sam rushes the paper, completely misses the core command word requirements, and loses easy marks. Both of them fail to hit their potential for the exact same reason. They jump straight into complex algebra without actually reading the math prompt. Before we can start applying frameworks like point, evidence, explanation, and link, we absolutely must learn the vocabulary. If you misread one single symbol, you could solve a really complex problem flawlessly, but it'll be the entirely wrong problem.
All right, so here is your game plan for today's session. We are breaking down this entire syllabus into 6 logical categories. We'll start with basic punctuation, move through complex operations and functions, tackle calculus, hit exponentials, and finally, navigate vectors. Let's get right into it.
Part 1. Translating math punctuation.
Okay, I'm going to put 60 seconds on the clock in my head here for a quick visual challenge. Look closely at this table. What's wild is how visually similar symbols have drastically different meanings. You know the standard equal sign, right? But add a third line, and bam, you have is identical to, or is congruent to. Curve those lines, and now you're saying is approximately equal to. Mix a curved line with straight lines, and you're stating something is isomorphic to. You literally have to train your eyes to catch these tiny visual differences. Treating an is proportional to symbol, that little fish-looking guy, as a basic equal sign is exactly what cost students like Sam their top grades.
And this right here brilliantly illustrates the grammar of logical flow. In the Cambridge exams, getting top marks means proving exactly how you get from point A to point B. Look at the direction of these arrows. An arrow pointing right means implies. Pointing left means is implied by. And that awesome double-headed arrow? That is the ultimate statement, implies and is implied by, or equivalence. Using these correctly tells the examiner your logic is rock solid. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, moving on to part 2, decoding complex operations. Think of these symbols as the heavy action verbs of the math world. You've got the straight vertical bars giving you the modulus, the exclamation point, which is n factorial. But listen, the absolute most crucial point here is paying strict attention to the hidden conditions. Look at the square root symbol. In the 0606 syllabus, that basic square root symbol specifically translates to the non-negative square root for real numbers where a is greater than or equal to 0. Missing that non-negative constraint is a classic trap that will cost you points. And at the bottom, that big sigma means you're doing a grand summation.
Let's do a quick data scan. Notice how binomial coefficients appear in 2 totally distinct formats on the paper? You have the horizontal NCR notation, and then you've got this vertical, bracketed format that honestly looks just like a column vector. You have to instantly recognize that both of these visual formats translate to the exact same underlying factorial equation shown on the right. Recognizing synonyms in math is a total game changer.
Let's slide into part 3, the language of functions.
Functions are basically the mathematical machines of your exam. You put a number in, the machine goes to work, and a new number pops out. But notice how the notation shifts depending on what we're describing. The top row, f of x, is your standard output value. But rows 2 and 3, an arrow without a flat tail means a mapping between entire sets of numbers. Add that little vertical mapping bar to the tail of the arrow, and suddenly you're specifically tracking the journey of a single element x to element y. And remember, a -1 exponent here does not mean division. It represents the inverse function, running the whole machine in reverse.
Now check out composite functions. This is where we link multiple machines together. And order of operations is literally everything. When you see GF reverse, your brain naturally wants to read left to right and apply G first. Do not fall for it. The notation GF means you take your element x, apply function f first, and then feed that result into function g. Always work from the inside out. Now stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @aceexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Part 4, Calculus and Limits.
We have officially reached the dialect of change. In calculus, precision in your notation isn't just a nice-to-have, it's absolutely vital. Sloppy notation here will tank your mark potential. Before deriving anything, you have to grasp a limit. This notation means finding the value the function approaches as x tends toward or gets infinitely close to the value a. It's all about the journey, right? Not just the final destination.
Consider this slide your ultimate calculus survival cheat sheet. Seriously, mentally lock this in. Look at how derivative notation changes based on what you're measuring against. If you're differentiating with respect to x, you use dy dx or the prime notation. But if you're doing kinematics and differentiating with respect to time, t, you use dx dt, or that dot notation. 1 dot for velocity, 2 for acceleration. If you mix these up, the examiner is immediately pulling out the red pen. And at the bottom, make sure you never confuse an indefinite integral with a definite integral that has those tiny a and b boundaries.
Moving to Part 5, Exponentials and Circular Functions.
Okay, let's play Find the Flaw for a second. Imagine a student is rushing, they see an L and an N or an L and a G, and they just treat them as the same thing in their calculator. Massive flaw. ln(x) strictly means the natural logarithm to the base e, but lgx, or log 10x, translates exclusively to base 10. Mixing these up is a guaranteed way to completely ruin an exponential decay calculation. Precision is everything.
With trigonometry, the syllabus demands absolute 100% fluency. You can't just know sine, cosine, and tangent anymore. You need to instantly recognize their reciprocals, cosecant, secant, and cotangent. And just like we saw with the machine functions earlier, that -1 exponent dictates the inverse circular functions. You've got to be able to speed read these without even blinking.
And finally, Part 6, Navigating Vectors.
Vectors can be pretty slippery because they shapeshift into different formats. A vector might just be a bold letter A, or it could be a directed line segment from A to B with an arrow on top. See those vertical bars in row 3? We saw those with modulus earlier, but in vector land, they mean magnitude, the actual length of the vector. And that stacked column vector at the bottom translates directly to xi plus yj. No matter how they disguise it, you have to recognize they are all describing quantities with magnitude and direction.
Here's one last crucial distinction: unit vectors. These guys have a precise magnitude of exactly 1. You absolutely must differentiate between a general unit vector, that little a hat on the left, and the Cartesian unit vectors I and j on the right. That a hat vector can point literally anywhere, as long as it lines up with vector a. But I and j, no way. They are rigidly locked to your horizontal x and vertical y axes.
So, there it is. By viewing mathematical notation as a highly structured language, you've just unlocked the ultimate framework for exam mastery. When you combine this vocabulary with the 3 golden rules, command word decoding, Peel framework application, and a strict time management matrix, your mark potential shoots to 100%. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.